convert 245 decimal into binary using the method in Stroud. How we're going to do this is to divide continuously by 2. We're dividing by 2 because we're going to binary, and binary is base 2. So we start with 245 divided by 2. That goes into 2 goes into 2 once, 2 goes into 4 twice, and 2 goes into 5 remainder 1. So we divide 122 by 2. 2 goes into 12 6 times, 2 goes into 2 once, and there's no remainder. Divide 61 by 2 and we get the answer of 30 with the remainder 1. Divide 30 by 2, we get 15, remainder 0. Divide 15 by 2, we get 7, remainder 1. Divide 7 by 2, we get 3, remainder 1. Divide 3 by 2, we get 1, remainder 1. And then finally divide 1 by 2, we get 0, remainder 1. Now we've reached 0, we've actually done the conversion. So now what we want to do is we want to take this column of numbers and let it fall like a tree so that it just falls over. So we get that one there is that one there. So that's where that mapping, and that one there is that one there. So that's the mapping there. Which means that our answer is 11110101, but we'll never calculate an answer without checking it. We'll do the sanity clause. So we'll write a table like this, which is the binary table. If this was decimal, this would be 1, this would be 10, this would be 100, this would be 1000, and so on. But in binary it's 1 times 2 is 2, times 2 is 4, times 2 is 8, 16, and so on. And we put the first one there into here, the second one goes into there, and so on. So those are the numbers, and now we add them together. 128 and 64 is 180, 192. 192 and 32 is 224. 224 and 16 is 234, 240. 244, 245. Okay, so that means that our conversion here works out here. So we can say that the conversion of 245 in decimal is equal to that, and we got the answer right. Okay, for the next question we're going to convert 245 decimal into hexadecimal, again using the method described in Stroud. So we'll divide continuously by 16 because we're converting into hexadecimal. 16 squared is 256. This is a little bit less than 256, so this is probably 1516, something like that. So let's try it. If we do 16 times 15, so that will give us 160 when we multiply by 10, and then 80 when we multiply by 5, because that's half of it, so that's 240. Okay, so 240 take away from 245 will give us the answer 5, so that's okay. So that means that 16 goes into 245 15 times with a remainder of 5. If we divide 15 by 16, it goes in no times, and there's a remainder of 15, which is the same as f in hex. As before, we take that column and we allow it to fall over like that, which means that the most significant digit is f and the least significant digit is 5. So 245 decimal is equal to f5 hex. As before, we need to check it. If this was base 10, this would be 1 and this would be 10, but because we're in base 16, this is 1 and this is 16. So the f goes here and the 5 goes there. 16 times 15, as we've already calculated, is 240, plus 5 means it's 245, so the answer is right.